Hi friends, in this video we're gonna see the cascaded form of realization. In the previous videos we have seen direct form 1 method, direct form 2 method, here cascaded form. So in this method we'll take our transfer function h of z, we'll write it in the product form. Product of two or more transfer functions. So what is a cascade form? It means the boxes are connected in series, right? The systems are connected in series. This will be my h1 of z, h2 of z, h3 of z, so on. Okay. For the first one, I'll give an input of x1 of n. So I'll get output of y1 of n. For the second one, I'll give input as x2 of n. I'll get y2 of n. Similarly, x3 of n, this will be my y3 of n up to yn of n, so on. Okay, so these all are connected in series. Okay, in this method we use direct form 2 for realization. That means we use less number of delays rather than more number of delays. First, we'll see this with an example. So this is the question given: y of n equal to 3 by 4 y of n minus 1 minus 1 by 8 y of n minus 2 plus x of n plus 1 by 3 x of n minus 1. Now apply z transform on both sides. We get y of z is equal to 3 by 4 z inverse into y of z minus 1 by 8 z power minus 2 into y of z plus x of z 1 by 3 x of z into z inverse, right? Directly write y of z by x of z, which is my h of z, that will be equal to 1 plus 1 by 3 times z power minus 1 by, this is 1 minus 3 by 4 z inverse plus 1 by 8 z power minus 2. Okay, now after simplification of the denominator into the partial fractions, we have this as 1 plus 1 by 3 z inverse by 1 minus 1 by 2 z inverse into 1 minus 1 by 4 z inverse. Okay, I am splitting my denominator part into partial fractions, so I get this as my partial fractions output. Now here consider any two things as h1 of z into h2 of z. So I make this one as h1 of z 1 plus 1 by 3 z inverse by 1 minus 1 by 2 z inverse, whereas my h2 of z will be 1 by 1 minus 1 by 4 z inverse. Now try to realize them separately using the block diagram. After that we'll cascade, we'll add both of them, right? Okay, so initially, so here it is z inverse, that means it is clear that I need to use only one delay for both the things. So only one delay. Then next is, now what is my h1 of z? It is y1 of z by x1 of z, right? 1 by 1 plus 3 z inverse by 1 minus half z inverse. Now when I cross multiply this, what I get is y1 of z is equal to 1 by 2 z inverse y1 of z plus x1 of z plus 1 by 3 x1 of z into z inverse. Now this is my y1 of z. So here it should be my y1 of n, right? Here should be my y1 of n. After the summer, now I'll come from the x1 of n side. x1 of n should be added with 1 by 3 x1 of z inverse, right? So x1 of n, this will be my x1 of n. It's the same direction. This x1 of n is denoted by z inverse time, one time unit. So my amplitude should be this one. This is x of n minus 1. This term 1 by 3. Okay. This is my y1 of n. Similarly, now this is my y1 of n. This is delayed by z inverse time unit. Okay, one time unit, and the amplitude is 1 by 2. Okay. So this is my x1 of n. This is my y1 of n. This is the first function realization. This is my h1 of z. Next thing, h2 of z. Same, y2 of z by x2 of z 1 by 1 minus 4 z inverse. This will be y2 of z equal to 4 into y2 of z in z inverse plus x2 of z, right? So again this will be my x2 of n. Sum, I need one delay, and this is my y2 of n, which is also equal to my y of n. So here y of z is given by it's 1 by 4. My coefficient is 1 by 4 here. So I'll add to this one. As only x2 of z is there, directly my x2 of n is sufficient. Okay. So this is my second block. Okay. Now, whenever I am connecting in series, my y1 of n becomes my x2 of n for the my output of first block becomes second input to the second block, right? So just what you do is cascade them. That means remove x2 of n, remove y2 of n, and directly add them both, giving rise to y2 of n, which is equal to y of n. Giving rise, the input should be x of n. Now this is how we realize the cascade form. Okay, first take the z transform of the given filter function. Okay, after given filter equation, after that split the z transform or split the given filter function into two parts, h1 of z and h2 of z, or if it is three parts, h3 of z, and realize them separately. Finally add them. Okay, and we use direct form 2 method for cascade realization, because we are using only single delay but operating with two different signals, y of n and x of n. Okay. Similarly, we see another example here. This h of z is equal to 1 plus 3 by 4 z inverse plus half z inverse 2 by 1 plus z inverse plus 1 by 4 z inverse minus 2 into 1 minus half z inverse plus z inverse minus 2 1 plus 1 by 4 z inverse plus half z inverse minus 2. So here this is the question given here directly. So if you can see this, they have directly given us h1 of z and h2 of z. This is my h1 of z and this is my h2 of z, right? And so what we do is take h1 of z, similarly take h2 of z. Right? Now realize them individually and finally add them. Okay? Now if we realize them, you need to consider this as y1 of z by x1 of z. Clearly, we need to use two delays here because z inverse is there, z power minus 2 is there. One delay, two delay, right? And this will be my x1 of n, okay? This will be my y1 of n, okay? Now y1 of 1 is y1 of when we cross multiply this, y1 of z plus y1 of z into z inverse. So y1 of n is as a coefficient of 1. y1 of z into 1 by 4 z inverse 2. Here I need to have some adder. This coefficient is 1 by 4. Similarly, x1 of z plus 3 by 4 into z inverse. 3 by 4 into z inverse. And again one more adder here. The second thing is half into z power minus 2. Okay, this is my x1 of n and y1 of n. Similarly, here this will be x2 of n adder, x2 of n adder, and I can consider this to be y2 of z by x2 of z. So this will be y2 of z, and again one more adder here, giving rise to y2 of n. Okay. As it is z power minus 2, here also it requires two adders. Okay, I mean two delays and two adders, right? Now y2 of n is y2 of n plus 1 by 4 z inverse. So it is 1 by 4. Next coefficient is 1 by 2 here, both should be added. Similarly, my x2 of n, this is my minus half, x2 of n into half into z inverse. Last thing is 1, right? This is my x2 of n, this is my y2 of n, this is my y2 of n. Now just remove these y2 of n, x2 of n terms, okay, and extend this line here and remove this y2 of n, it is y1 of n. Remove this x1 of n and replace with x of n. Right? This is my cascaded form realization of given h of z. Now this is how we realize the given transfer function in cascaded form. That's all for this video. Thank you.